First thing I'd like to do, however, is get a little bit of a comparison between the old way of working with this parabola and the new way. Previously, we had the equation y is equal to a times x minus h squared plus k. Now, for the new way, we would really like to have that x minus h squared by itself on one side of the equation. So I'm going to begin by subtracting k off of each side, writing y minus k is equal to a times x minus h squared. And then dividing through by a, we will have 1 over a times y minus k is equal to x minus h squared. And if you don't mind, I'm going to rearrange this just a little bit and write it as x minus h squared on the left is equal to 1 over a times y minus k. Okay, that is the old way kind of rearranged to look like the new way. Now the new way has the equation we just learned a moment ago, x minus h squared is equal to 4p times y minus k. And if we look at the two of these side by side, they only differ by the coefficient in front on the right hand side of the equation. In other words, we have 4p is equal to 1 over a, relating these two forms. And if I multiply each side of this by a, I will have 4ap on the left is equal to 1. Now, let's take this 4ap equals 1 and solve it for either a or p. Solving it for a, I have a equals 1 over 4p, or solving it for p, I get 1 over 4a on the right. In other words, if you have the value of p and you want to know what is the value of a, you can plug it into this first formula. Or if you have a from the old way of looking at the parabola, you can substitute it into this formula and isolate p, the distance between the center and the focus or directrix. So here's a way of converting back and forth if you're stuck into the old way of looking at the parabola. And we have a chart down below here which pretty much summarizes what I have already described to you at the left.